Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm Anna.
And I'm Avery. Thanks for joining us on this Saturday, January 31st, 2026.
We've got a fascinating lineup today, covering everything from NASA's Artemis program updates to groundbreaking discoveries in the search for life beyond Earth. Avery, what's on the agenda?
Well, Anna, we're kicking things off with some news from NASA's Artemis 2 mission. There's been a delay in critical testing due to some unexpected weather challenges. Then we'll dive into Blue Origin's strategic shift as they pause their space tourism program for at least 2 years.
After that, we're looking up at some truly cosmic phenomena. Million-mile-per-hour winds racing through colliding galaxies, and a mysterious object sending powerful signals across space that has astronomers scratching their heads.
We'll also explore some surprising findings about Tatooine-style planets orbiting binary stars, and wrap up with an exciting discovery. Scientists have detected a molecule critical to life in interstellar space for the very first time.
Quite the journey today. Let's get started.
Ready when you are.
All right, Avery, let's start with NASA's Artemis program. I understand Old Man Winter has thrown a wrench into their testing schedule.
He certainly has, Anna. NASA has been forced to delay a critical fueling test for the Artemis 2 mission due to below freezing temperatures at Kennedy Space Center in Florida. The wet dress rehearsal was originally scheduled for January 27th, but those unexpected cold temperatures put it on ice, so to speak.
I see what you did there. But seriously, what exactly is this wet dress rehearsal, and why is it so important?
Great question. The wet dress rehearsal is essentially a full practice run of launch day procedures, minus the actual launch. The team loads the massive Space Launch System rocket with over 700,000 gallons of super cold liquid hydrogen and liquid oxygen propellants, runs through all the countdown procedures, and then drains everything back out. It's the ultimate dress rehearsal before the real show.
So they're basically making sure all the plumbing works and everyone knows their roles when the clock is ticking down. What happened with the weather that caused the delay?
Well, Florida experienced some unusually cold conditions. We're talking about freezing temperatures that persisted for several days. The problem is that loading these cryogenic propellants in freezing conditions creates additional safety risks and potential technical issues. NASA's priority is always safety first, so they made the call to postpone.
Smart move. When are they planning to try again?
The Space Launch System is now set to roll out to Launch Pad 39B on February 5th, with the wet dress rehearsal rescheduled for February 8th. This means the Artemis 2 launch is now no earlier than April 2026, which is a shift from the previous March target.
For our listeners who might not be following every detail of Artemis, remind us what makes Artemis 2 so significant.
Hannah, Artemis 2 is absolutely historic. This will be the first crewed mission beyond low Earth orbit in over 50 years, basically since the Apollo program ended. 4 astronauts will fly around the moon, testing all the systems and procedures that will eventually support landing astronauts back on the lunar surface during Artemis 3.
It's wild to think we haven't sent humans beyond Earth orbit in 5 decades. Who's on the crew?
The crew includes NASA astronauts Reed Wiseman, Victor Glover, and Christina Koch, along with Canadian Space Agency astronaut Jeremy Hansen. Victor Glover will make history as the first person of color to travel beyond low Earth orbit, and Christina Koch will become the first woman to do so.
That's incredible. Even with this delay, April 2026 is right around the corner. The wait is almost over.
Absolutely. And honestly, a few weeks delay to ensure everything is perfect is well worth it when you're pioneering the return of human deep space exploration.
Speaking of human spaceflight, let's shift gears to Blue Origin. They're making some significant changes to their program, aren't they, Avery?
They sure are, Anna. Blue Origin has announced they're hitting pause on their new Shepard space tourism flights for at least 2 years. This is a major strategic shift as they refocus their resources on NASA's Artemis program and the development of their lunar lander.
2 years is a substantial pause. What's driving this decision?
It all comes down to their Blue Moon lunar lander program. Blue Origin won a contract from NASA worth potentially up to $3.6 billion to develop a human landing system for the Artemis missions. They're planning an uncrewed demonstration mission to the moon in 2028, and that's requiring a massive concentration of their engineering talent and resources.
So they're essentially choosing moon landings over suborbital tourism flights. That seems like a pretty clear indication of where they see the bigger opportunity.
Exactly. And it's worth noting that Blue Origin has already conducted 8 successful new Shepard tourism flights since July 2021, carrying 43 people past the Kármán line, the internationally recognized boundary of space at 100 kilometers altitude. So they've proven the concept and the technology.
I remember the excitement around those early flights. What exactly will passengers experience on a new Shepard flight?
It's a roughly 11-minute journey where passengers experience about 3 minutes of weightlessness at the top of the arc. The capsule has massive windows, the largest ever flown in space, giving spectacular views of Earth's curvature and the blackness of space. It's suborbital, meaning you go up and come right back down, but you definitely cross into space.
And this pause is specifically for the tourism program. What about other New Shepard missions?
Good distinction, Anna. New Shepard will continue flying cargo and research missions. Blue Origin has committed to conducting at least 2 cargo flights each year during this tourism pause. These missions carry scientific experiments and payloads for various customers, including NASA.
What about their ticket sales? I imagine people have already paid for future flights.
Yes, and Blue Origin says they'll be contacting customers who've already purchased tickets to discuss their options. They haven't specified how many people are affected, but they've emphasized this is a temporary pause, not an end to the program.
It's interesting timing, isn't it? Just as several companies are getting into the space tourism business, Blue Origin is stepping back, at least temporarily.
It really shows you the scale of the Lunar Lander Challenge. Building a spacecraft that can safely land humans on the moon and return them to lunar orbit is orders of magnitude more complex than a suborbital tourism op. Blue Origin is betting their future on being a key player in the new era of space exploration.
And with that NASA contract potentially worth $3.6 billion, it's not hard to see why they're prioritizing it.
Exactly. This is Blue Origin's moonshot, both literally and figuratively. If they can deliver a successful lunar lander, it positions them as a major player in the new era of space exploration.
From human space exploration to cosmic phenomena, let's talk about something happening on a scale that's almost impossible to comprehend. Avery, tell us about these million-mile-per-hour winds racing through space.
Anna, this is absolutely mind-blowing. Astronomers have discovered cosmic winds traveling at over 1.1 million miles per hour. That's roughly 500 kilometers per second, racing through what they're calling a magnetic superhighway between 2 colliding galaxies.
A magnetic superhighway in space? That sounds like something out of science fiction. Where is this happening?
This incredible phenomenon is occurring in a system called IC 1623, which is actually 2 galaxies in the process of merging together, located about 275 million light-years from Earth in the constellation Cetus. These galaxies are in the late stages of a cosmic collision, and it's creating some extraordinary physics.
Walk us through what's actually happening here. How do galaxies colliding create these super fast winds?
When galaxies merge, their gravitational interactions trigger massive bursts of star formation. We're talking thousands of stars being born. These newborn stars live fast and die young, creating powerful stellar winds and supernova explosions. All of this activity generates enormous amounts of energy that drives material outward at incredible speeds.
And the magnetic superhighway? What role does that play?
Here's where it gets really fascinating. The team from the University of Hertfordshire discovered that magnetic fields are actually channeling these winds, creating what they call a superhighway that connects the 2 galactic cores. Think of it like a cosmic interstate highway system. But instead of cars, you've got superheated gas screaming along at speeds that make Earth's fastest spacecraft look like they're standing still.
That's an amazing image. How did they detect something like this?
They used the Atacama Large Millimeter Array, ALMA, in Chile, which is specifically designed to observe cold gas and dust in the universe. What they found was unexpected. The magnetic field structure doesn't just randomly radiate outward like many galactic winds do. Instead, it's highly organized, creating this directed pathway between the galactic centers.
Why is this discovery so significant? What does it tell us about galaxy evolution?
This is crucial for understanding how galaxies grow and evolve. These powerful outflows, what astronomers call feedback, can actually regulate star formation by expelling the gas and dust that would otherwise collapse to form new stars. It's like a pressure release valve for galaxies. Too much star formation can blow away the material needed to make more stars, which can eventually slow down or even halt a galaxy's growth.
So galaxies regulate their own growth through these winds? That's a pretty elegant self-limiting system.
It really is. And what makes IC 1623 particularly interesting is that we're seeing this process in action during a galaxy merger. When galaxies collide, we see the most extreme versions of these processes, the most intense star formation, the most powerful winds, the strongest magnetic fields. It's like watching galaxy evolution in fast forward.
What do we think the fate of IC 1623 will be?
Eventually, these two galaxies will completely merge into a single, larger galaxy. The current burst of star formation will eventually exhaust much of the available gas, and what we're looking at now, this spectacular phase of cosmic winds and magnetic highways, will fade. But the combined galaxy will carry the imprint of this violent event in its structure and stellar populations for billions of years to come.
It's humbling to think that we're witnessing something that takes millions of years to play out, just captured in a snapshot.
Absolutely. And every time we point our telescopes at merging galaxies, we learn something new about the forces shaping the universe's largest structures.
Speaking of pointing our telescopes at the universe and finding surprises, Avery, we need to talk about this mysterious object that's been sending powerful signals across the galaxy. The headline says it's unlike anything we have seen before.
That's not just hype, Anna. Astronomers have discovered something truly puzzling. A cosmic object that's periodically sending out intense radio signals. And it doesn't fit into any category of known astronomical phenomena. It's one of those discoveries that makes you rethink what you thought you knew.
Okay, you've got my attention. What exactly are we dealing with here?
The object sends out extremely bright radio pulses that last about 30 to 300 seconds. That's up to 5 minutes per pulse. And these pulses occur roughly every 2.9 hours with remarkable regularity. What makes this so unusual is the combination of that long period and the duration of the pulses themselves.
When you say it doesn't fit known categories, what are the usual suspects for objects that send out regular signals like this?
Great question. The two most common sources of periodic radio signals are pulsars and magnetars. Pulsars are rapidly spinning neutron stars that sweep beams of radiation across space like a cosmic lighthouse. But they typically pulse on the order of milliseconds to seconds, not hours. And their individual pulses are brief, usually milliseconds, not minutes.
So this object is pulsing way too slowly to be a normal pulsar.
Exactly. And the pulses last far too long. Magnetars, which are neutron stars with incredibly powerful magnetic fields, can sometimes produce longer period signals than regular pulsars. But even they don't typically operate on a 3-hour cycle with multi-minute pulse durations.
Have astronomers proposed any theories about what this could be?
There are a few possibilities being investigated. One idea is that it could be a white dwarf in a binary system, which is two stars orbiting each other where one is a white dwarf remnant. The interaction between the two stars can potentially generate these periodic radio emissions. Another possibility is that we're seeing some kind of unusual magnetar or pulsar that operates differently than the ones we studied before.
When was this object discovered and how?
The discovery was made using radio telescope observations. And what's particularly intriguing is that the signals are powerful enough to be detected across vast distances. The exact distance to this object is still being determined, but the fact that we can detect such clear, periodic signals suggests it's either relatively close in cosmic terms or it's putting out tremendous amounts of energy.
This reminds me of those fast radio bursts we've heard about. Brief, intense radio signals from across the universe. Is this related?
That's a natural comparison, Anna, but fast radio bursts, FRBs, are different. They're much briefer, typically lasting milliseconds, though some do repeat. This object's behavior is more periodic and predictable, with much longer pulse durations. It's almost like comparing a strobe light to a slowly rotating searchlight.
What's the next step for studying this mysterious object?
Astronomers will be conducting follow-up observations across multiple wavelengths, not just radio, but also optical, X-ray, and potentially others. They want to determine exactly where it is, measure its properties in detail, and hopefully identify what type of object it is. Sometimes you need multiple types of observations to build a complete picture.
Do discoveries like this happen often, where we find something that just doesn't fit our existing models?
More often than you might think, actually. The universe keeps surprising us. Every major improvement in our observing technology reveals new phenomena we didn't predict. Radio astronomy in particular has a history of unexpected discoveries. Pulsars themselves were a complete surprise when they were first detected in 1967.
Could this turn out to be a whole new class of astronomical objects?
That's definitely possible. If follow-up observations confirm that this truly doesn't fit into any existing category, it could indeed represent something new. Of course, it might also turn out to be an extreme example of a known type of object, just operating in a regime we haven't observed before. Either way, it's expanding our understanding of what's possible in the universe.
I love that we're still finding things that make astronomers say we've never seen anything like this before.
Me too, Anna. It reminds us how much we still have to learn about the cosmos.
Sticking with unexpected discoveries, let's talk about planets that orbit two suns, Tatooine-style worlds. Avery, I understand these aren't as rare as scientists once thought.
That's right, Anna. New research is challenging our assumptions about circumbinary planets. That's the technical term for planets that orbit both stars in a binary system. It turns out these Star Wars-style worlds might be more common than we previously believed, especially around certain types of binary stars.
Before we dive into the findings, let's set the stage. How common are binary star systems in the first place?
Binary systems are actually incredibly common, Anna. Roughly half of all sun-like stars exist in binary or multiple star systems. So we're not talking about a rare cosmic curiosity here. Binaries are a fundamental component of the galaxy's stellar population.
And we have discovered actual circumbinary planets already, right? This isn't just theoretical.
Absolutely. NASA's Kepler Space Telescope discovered the first confirmed circumbinary planets back in 2011, and we've found several more since then. These are real worlds orbiting two suns, just like Luke Skywalker's home planet. But the question has always been, how common are they?
So what does this new research tell us?
The study found that circumbinary planets appear to be particularly common around what are called equal mass binaries, systems where both stars are roughly the same size and mass. In these systems, the stable orbital zone where planets can form and survive might actually be more favorable than astronomers previously calculated.
Why would having two equal mass stars make it easier for planets to form?
It has to do with gravitational stability. When you have two stars of similar mass, their gravitational influence on the surrounding disk of planet-forming material is more balanced and predictable. There's less chaotic variation in the gravitational forces acting on the disk, which means there are stable regions where material can accumulate and grow into planets.
What about unequal binary systems, one big star and one small one?
Those systems can still host circumbinary planets, but the dynamics are more complex. The larger star dominates gravitationally, and the smaller star creates additional perturbations that can make certain orbital regions unstable. It doesn't mean planets can't form, but the stable zones might be more limited or located at different distances.
This has implications for the search for habitable worlds, doesn't it?
Very much so. If circumbinary planets are more common than we thought, especially in equal mass binaries, that increases the overall number of potential planetary environments in the galaxy. Some of these could potentially be in the habitable zone, the region where liquid water could exist on a planet's surface.
Although I imagine having two suns would complicate the climate situation significantly.
You're absolutely right. The climate on a circumbinary planet would be fascinatingly complex. You'd have variations in heating depending on the orbital positions of both stars relative to the planet. Some times of the year, both suns might be on the same side of the sky, providing intense combined heating. Other times, they'd be on opposite sides, creating more balanced illumination.
How did researchers arrive at these conclusions about circumbinary planet frequency?
They combined observational data from telescope surveys with sophisticated computer modeling of how planets form in binary star systems. By simulating thousands of different scenarios with various binary configurations, they could identify patterns about which systems are most likely to host planets.
Are there any specific systems astronomers are now targeting for follow-up observations based on these findings?
The research definitely points to equal mass binaries as high priority targets for planet hunting campaigns. Missions like NASA's upcoming Nancy Grace Roman telescope and continuing observations from ground-based facilities will be keeping a close eye on these systems. Every new circumbinary planet we discover helps refine our models.
It's exciting to think those iconic twin sunset scenes from Star Wars might be more common in the universe than we realized.
It really is, Anna. The universe keeps proving that the reality can be just as spectacular as science fiction, sometimes even more so.
And for our final story today, Avery, we're talking about a discovery that touches on one of astronomy's biggest questions, the search for life beyond Earth. Scientists have detected a molecule critical to life in interstellar space for the first time. Tell us about this breakthrough.
This is genuinely exciting, Anna. For the first time ever, astronomers have detected ethylenamine, a molecule that plays a crucial role in forming cell membranes, floating in the vast spaces between stars. This discovery has profound implications for how we think about the building blocks of life in the universe.
Let's start with the basics. What exactly is ethylenamine and why is it so important to life?
Ethylenamine is an organic molecule that's a key component of phospholipids, which are the primary building blocks of cell membranes. Think of cell membranes as the walls and gates of cells. They define the boundary between the inside and outside of a cell and control what goes in and out. Without molecules like ethylenamine, you can't build functional cell membranes, and without cell membranes, you can't have cells as we know them.
Though this is truly fundamental to life, at least life as we understand it, where was this molecule detected?
The discovery was made in a molecular cloud, one of these vast, cold regions of space where gas and dust accumulate, and where new stars and planetary systems eventually form. These clouds are essentially stellar nurseries, and finding life-building molecules there suggests that the ingredients for life might be getting incorporated into planetary systems right from the start.
How do scientists actually detect specific molecules in interstellar space? I imagine you can't exactly collect a sample.
Great question. They use radiospectroscopy. Every molecule has a unique spectroscopic signature. Think of it like a molecular fingerprint. Different molecules absorb and emit light at specific wavelengths. Radio telescopes can detect these signatures, allowing astronomers to identify what molecules are present in distant clouds, even though those clouds are trillions of miles away.
We've found other organic molecules in space before, haven't we? What makes this discovery special?
You're absolutely right, Hannah. Astronomers have detected more than 200 different molecules in interstellar space, including amino acids and sugars. But ethylenamine is special because of its direct connection to cell membrane formation. It's one thing to find amino acids, the building blocks of proteins, but finding a molecule that's essential for creating the actual structure of cells takes us another step closer to understanding how life's fundamental architecture might arise.
Does this discovery change our thinking about where the building blocks of life come from?
It definitely supports the hypothesis that many of life's essential molecular ingredients aren't created on planets after they form, but rather arrive from space. We already know that meteorites deliver organic compounds to planets. We found amino acids in meteorites that have fallen to Earth. This discovery suggests that even more complex life-related molecules could be delivered from space.
Though, in a sense, the raw materials for life might be common throughout the galaxy.
That's the tantalizing possibility this raises. If molecules like ethanolamine can form in the harsh conditions of interstellar space, then these building blocks might be present in molecular clouds throughout the galaxy. Every time a new planetary system forms, it could be inheriting these pre-made components of life.
This doesn't mean life is automatically everywhere, though, right? Having the ingredients doesn't guarantee you'll bake the cake.
Exactly. This is about potential and possibility. Having the molecular building blocks is necessary for life, but it's not sufficient. You still need the right conditions for those molecules to assemble into functioning biological systems. The right temperature, pressure, energy sources, solvents like liquid water, and probably a host of factors we don't fully understand yet.
What are the next steps for this kind of research?
Astronomers will be looking for ethanolamine and similar molecules in other molecular clouds to see how widespread they are. They'll also be searching for even more complex organic molecules that might be precursors to biological chemistry. Every molecule we find helps us piece together the story of how inanimate chemistry transitions to the chemistry of life.
It's remarkable to think that the membrane surrounding every cell in our bodies might have had their chemical ancestors floating between the stars billions of years ago.
It really is, Anna. It connects us to the cosmos in a very tangible way. We're not just made of stardust in an abstract sense. The actual molecular machinery of life may have origins that predate Earth itself.
What a perfect note to end today's episode on. A reminder that we're part of a universe-wide chemistry experiment that's been running for billions of years.
Well, that wraps up another day of space and astronomy news. From NASA's Artemis preparations to the discovery of life's building blocks floating between the stars, the universe continues to amaze and inspire.
It really does. Thanks so much for joining us today, everyone. Remember, you can find us at astronomydaily.io for full episode transcripts and additional content.
And don't forget to follow us on social media at Astro Daily Pod for daily updates and space news throughout the week.
Until next time, keep looking up.
Clear skies, everyone!
Astronomy Daily.